Hey guys, in this video I am going to review the methods of finding roots for polynomials that we've learned in class, and then I'm going to give you a couple of examples that use all of the different methods that we've talked about in different orders. So the first thing that you should try when you're given a polynomial and asked to find the root is see if it factors. Most of the polynomials that you encounter will not factor, but it's worth a try because it is one of the easier methods. The two common types of factoring that you will see in these problems are factoring by grouping, which we can use for any polynomial with 4 terms, and then the diamond method, which works for polynomials with 3 terms. If you do not know how to do these factoring methods, you can check on Khan Academy. They have some videos on there that would be helpful, or you can ask me for help in class or find a classmate who knows how to do them. If your polynomial doesn't factor, which most of them won't, then the next thing that you can check real quickly is see, can I use the quadratic formula? The quadratic formula only applies in very specific cases, and that's for any trinomial, so anything with 3 terms, that has consecutive exponents. So this means that the quadratic formula, remember, only works if we have something like x squared and then x and then a constant, or x to the 6th and then x to the 5th and then x to the 4th. The exponents have to go in order, and you can't skip any terms. You can take out a GCF and then use the quadratic formula. So if factoring and the quadratic formula won't work, then the last option that we have is synthetic division. And if you don't know how to do synthetic division, you can look at the video for section 5-4, which says dividing by polynomials. And for synthetic division, I would recommend always try dividing by 1 and -1 first. And if that doesn't work, then your next option would be to list possible roots using the rational root theorem, which was what we learned in section 5.5, and there's also a video for that. And then once you've listed all of those roots, just go down your list and try the possible options. So for synthetic division, again, start with 1 and -1. If those work, then you don't have to worry about making your whole long list. If they don't work, then we would turn to the list for the other numbers we might want to try. So let's jump into some examples. So our first example, we have p of x equals x cubed plus 4x squared minus 5x minus 14. And I'm just going to run through my methods and see which ones I can use. So when I first look at this polynomial, it has 4 terms, so I might try factoring by grouping, and we'll give that a try real quick. If I group together my first 2 terms and group together my second 2 terms, notice that I'm grouping the negative in front of the 5 inside of that group, and then I'll put a little plus in between my sets of parentheses. Then take out a GCF for each group, and I have x squared and x plus 4. For my second group, I don't have a GCF. I could take out a -1 if I wanted. And then I have 5x plus 14. And now I see that grouping doesn't work. Remember that in order for grouping to work, the leftover things in parentheses have to be the same, and here they're not. So grouping doesn't work. That's out, and I can't use factoring. So no grouping, no factoring. Then I could check and see if the quadratic formula would work, but I know right away that it can't because I have 4 terms instead of 3. So the only option that I have left is synthetic division. So for my synthetic division, I'll start by trying +1 and just hope that we get lucky and this works. So remember, for synthetic division, I put the number I want to divide by in a little box, and then I list the coefficients from up here in my polynomial. So that will be 1, 4, -5, negative 14. I bring down the 1 because it's the first coefficient and multiply by the number in the box. 1 times 1 is 1. Add straight down to get 5. Multiply by the number in the box. 5 times 1 is 5. Add straight down and I get 0. Multiply by the number in the box. That gives me 0. Add straight down and I get negative 14. Since the remainder is not 0, then this means that 1 is not a root. So now I'll need to move on and try a different number. The next number that I'm going to try is negative 1, so I've set up my synthetic division here for negative 1. Bring down the 1, multiply by the number in the box. 1 times negative 1 is negative 1. Add straight down, and I get 3. Multiply by the number in the box. That's negative 3. Add straight down, and I get negative 8. Multiply by the number in the box. That's 8. Add straight down, and I get negative 6. Still not 0, so negative 1 is also not a root. So I've tried my two default options of 1 and negative 1, and now to know what other numbers are options, I need to use the rational root theorem. Okay, so we're going to use the rational root theorem. I have rewritten it, the polynomial here for you just for reference. And remember, for the rational root theorem, we need to find the factors of the constant and the factors of the leading coefficient. Our constant in this case is negative 14. Remember, we could use positive or negative 14. It doesn't matter because in the end, we end up using positive and negative numbers anyway. So I'll just use positive 14. And the factors of 14 are 1, which we already tried, 2, 7, and 14. The factors of the leading coefficient in this case, the leading coefficient's just 1, and the only factor of 1 is 1. This makes our list nice and simple. Our list of possible numbers is 1, negative 1, 2, negative 2, 7, negative 7, and 14, and negative 14. So these are all of the numbers that we would want to try for synthetic division. Remember, we've already tried 1 and it didn't work. We tried negative 1 and it didn't work. So now we'll move on and try 2 and see if that gives us a root. So back to synthetic division here. I've set up our synthetic division with 2 in our box and the same coefficients from our polynomial. Bring down the 1 and multiply by the number in the box. 1 times 2 is 2. Add straight down and we get 6. Multiply by the number in the box. 6 times 2 is 12. Add straight down. Negative 5 plus 12 is 7. Multiply by the number in the box. That's 14. Add straight down. And finally, we get 0 as a remainder. This means that 2, x equals 2, is a root. So we found one root. And we're ready to move on and see what method we might need to use to find the other roots. So when we use synthetic division and we find a root, this actually simplifies our polynomial quite a bit. And now instead of looking for the roots of the original polynomial, we can use these leftover numbers here, 1, 6, and 7, to make a new simplified version of the polynomial. This will be x squared plus 6x plus 7. And now I can try factoring, or the quadratic formula on this, because now it's a trinomial. So we have one root, and we can use a different method to find the other roots for this new polynomial. Let's try factoring using the diamond method and see if that works before we resort to the quadratic formula. So if we use the diamond method here, and in fact we can use the diamond shortcut because there's no number in front of the x squared, we need two numbers that multiply to 7 and add to 6. The only two numbers that multiply to 7 are 1 and 7, or -1 and -7, and neither of those options will add together to give me 6. So the diamond method doesn't work. And this tells me that I have to use the quadratic formula. So for my quadratic formula, I'll be using x squared plus 6x plus 7. This means a is 1, b is 6, and c is 7. And the quadratic formula, if you don't have it written down somewhere, I'll write it again, is negative b plus or minus square root b squared minus 4ac divided by 2a. So I'm going to go ahead and fill this in quickly. Here we have it with all of the numbers plugged in, and then we want to simplify this as much as we can. So simplifying underneath the square root, I'll go step by step. We have square root of 36 minus 28 divided by 2 times 1, which is just 2. 36 minus 28 will give me square root of 8 divided by 2. And if you leave it at this point, that's mostly okay. There's a little bit more simplifying that we can do, and I'm going to go ahead and do that simplifying. If you left it here on a quiz or a test, say, you would probably only miss about half a point or a point, but I think that it is worth looking at how to simplify these in case it comes up on something like the SAT or a more important test later on. So we're going to go through this in detail of how to simplify a root. So just a little sidebar over here. Simplify square root of 8. So when we simplify roots, we're going to take the thing underneath the root and start breaking it down into numbers that multiply. So 8 is 2 times 4, 4 is 2 times 2, and then each of these 2's, they can't break down into anything else besides 1 and 2, but we don't need to do that. So now because this is a square root, that means it's like there's a little 2 on my root here. I'm going to be looking in my factor tree for groups of 2 prime factors. So here I have a group of 2 2's, and this means one of these 2's will go in front of the root. And then whatever doesn't have a pair or a group, so this little leftover 2 here that I've boxed, is going to go back underneath whatever type of root we had to start with. So the square root of 8 simplifies to 2 root 2. So going back over here to where we're writing our problem, I have negative 6 plus or minus 2 square root 2 divided by 2. And I have one more step in simplifying, and that is looking at these 3 numbers here, negative 6, the 2 outside of the root, and the 2 in the denominator. If all 3 of these numbers have something in common, we can divide them all by that number. So we can divide each of these numbers by 2 and end up with negative 3 plus or minus 1 root 2 divided by 1. And in this case, we don't really need either of these ones here, and we can just write -3 plus or minus root 2. So these are the other two roots of my polynomial. Because I have the plus or minus, that means one of the roots is -3 plus root 2, and the other is -3 minus root 2. So putting together all of this that we just did for this one problem, I'm going to write all of my roots in the same place. Individually listed. So the first root that we found using synthetic division over here was x equals 2. And then the other two roots that we found using the quadratic formula, if I write them separately, are -3 plus root 2 and -3 minus root 2. So I have 3 roots, which makes sense because our polynomial had degree 3. And finally, we are done with this beast of a problem. So that problem that we just finished used synthetic division and the quadratic formula, and we tried factoring at some point in there. Let's look at another example that maybe uses some different methods. So here's my next example, and I see again that this has 4 terms, and I take note that the exponents are cubed and then squared and then first power and then a constant, in case that's important later for synthetic division. And since it has 4 terms, I'm going to try grouping again and see if maybe it will work for this one. So we try grouping, and I group together my first 2 terms and my second 2 terms. In the first group, I can take out an x squared, and I have x plus 10. But in my second group, I don't have a common factor for 29x and 20. I can take out a 1, but then that leaves me with 2 leftover parenthesis parts that don't match. So this is another case where grouping just doesn't work. And we know the quadratic formula won't work because we have 4 terms. So we have to try synthetic division again. So I'll start my synthetic division the same way I did last time, and that's trying 1 and -1 first. So here's my setup for synthetic division with 1. I put the 1 in the box, and then I use the coefficients from my polynomial, 1, 10, 29, and 20. I bring down the 1, multiply by the number in the box, and that's 1. Add straight down. 10 plus 1 is 11. Multiply by the number in the box. 29 plus 11, add straight down, and I get 40. Multiply by the number in the box, and that's 40. Add straight down, and I get 60. Since the remainder is not 0, -1 is not a root. Oh, I apologize. +1 is not a root. We haven't tried -1 yet. So we'll try synthetic division now for -1. Set up our synthetic division the same way with the same coefficients. Bring down the first coefficient, which is 1, multiply by -1, add straight down, 10 plus -1 is 9. Multiply by -1 to get -9, add straight down, 29 plus -9 is 20. Multiply by -1 to get -20, add straight down, and we get 0. This means that -1 is a root. This is good for us because it means we don't even have to use the rational root theorem, and we don't have to do any more synthetic division. So we've done our synthetic division, we found one root, and we have our leftover numbers at the end of synthetic division that give us a new polynomial to work with. So from now on, we'll be looking at a trinomial, x squared plus 9x plus 20. With trinomials, the first thing that I will try is factoring using the diamond method. Since this trinomial has a leading coefficient of 1, which means there's no number in front of the x squared, I can actually use the diamond method shortcut. So for my diamond, I'll need to find two numbers that multiply to 20 and add to 9. And we are in luck because those two numbers exist and they are 4 and 5. 4 times 5 is 20, 4 plus 5 is 9. Since we're using the shortcut method, this tells me that I can automatically factor into x minus 4 and x minus 5. Scratch that, x plus 4 and x plus 5, which give me roots of x equals negative 4 and x equals negative 5. So I have two roots from using the diamond method, and I had one root from synthetic division. So we are done with this problem. And I'll list out my roots in one place. So if I put all three roots together, I have x equals negative 1, x equals negative 4, and x equals negative 5. We have three roots because our polynomial started with degree 3, and we're done. So our second example used synthetic division and then factoring, in this case using the diamond method shortcut. Our last example for this video is p of x equals x cubed plus 343, and we want to find all roots. So when I look at this polynomial, hopefully by now you are able to notice when something kind of special is going on. This is a special polynomial because x cubed and 343 are perfect cubes. So we can actually factor this one using a different method than what I listed originally. And this one will be the sum of cubes. So as a reminder, when we're factoring using sum of cubes, we want to look at the two things that we're working with and figure out what thing or number did we have to cube to get this. So to get x cubed, we would have cubed x. And to get 343, we must have cubed 7. So we'll be using x and 7 to factor this. So we have first a binomial that just uses x and 7. And I'm going to wait to fill in the signs in a minute here. And then we have a trinomial where we square each of these things. So x squared. And then we're going to leave a big space in the middle and do 7 squared, which is 49. And then finally we multiply together the two things, x times 7, and that goes right here in the middle. So 7x would be the more standard way to write that. So I have all of my little pieces, and now I just need to remember how to put my signs in place. And remember that's the acronym SOAP, which stands for same sign, opposite sign, always positive. So since I started with a plus right here, the same sign would be plus, the opposite sign would be minus, and then the last sign is always positive. So I was able to factor this, and looking at my factored form, so let me zoom in right here, this factored form actually gives us one of our roots already. This x plus 7 factor gives me a root of x equals negative 7. But this other piece over here, the trinomial, doesn't give me any roots quite yet. I still need to do something to this to find the roots. And I'll give you a little secret here. And that's when we use sum or difference of cubes, this part, the trinomial that we end up with, won't factor. So you don't even have to try factoring. I can tell you it won't factor, and instead we'll have to use the quadratic formula. So I'm going to go ahead and set that up, and then we'll work through it. So I've written out the quadratic formula again, and I listed my a, b, and c. Notice that in this case, b is -7 because there was a negative in front of the 7x term. So when I plug this in to the quadratic formula, the first part of the quadratic formula is -b. -7 actually gives me +7, plus or minus square root. And when we do b squared, we want to put the -7 in parentheses if we're doing this in our calculator. So we have -7 squared minus 4 times 1 times 49 divided by 2 times 1. Moving on to calculate this, we have 7 plus or minus. Underneath the square root, we'll have 49 minus 4 times 49, which is 196 all over 2. 49 minus 196 is the square root of -147 divided by 2. And now I want to see if -147, if I can simplify that at all since it's underneath the square root. So we'll do a little sidebar and start breaking 147 down into its factors. So 147 is 3 times 49, and then 49 is 7 times 7. Since this is a square root, I'm looking for groups of 2. I have 2 7s. That means one of those 7s will go outside of the root, and then I have this leftover 3 that's by itself, which goes back underneath the root. So this is what it simplifies to. Since there was a negative under the root to begin with, I'm going to put an I on the outside of the root so that we can make the thing under the root positive. So when you have a negative under the root, you just get rid of the negative and put an I on the outside. So our final answer is 7 plus or minus. You can write this in whatever order you want. I'm going to write 7I times the square root of 3 divided by 2. And there are our other 2 roots. Let's put all of our roots together in one place. And we have x equals, from our factoring, we found x equals -7. From our quadratic formula down here, we had 7 plus or minus 7i root 3 over 2. If I write those separately, that's 7 plus 7i root 3 over 2. And 7 minus 7i root 3 over 2. And there's our 3 roots for our degree 3 polynomial. So there you have 3 examples that use different methods. The first example we used synthetic division and the quadratic formula. The second example we used synthetic division and then factoring. And the third example, we used factoring and the quadratic formula. These are only some of the ways that we can find the roots. You can really combine factoring, synthetic division, and the quadratic formula in any type of way to find the roots, depending on the problem that you're working with. But hopefully this helps for some of the examples that you'll encounter.